Colony PCR is another type of experiment that we can do the screening of the bacterial colony to check that the insert has been ligated to the vector. So this colony PCR is a simple screening process, and it actually takes less time and less money. So what are the key steps of this colony PCR? As you uh, remember, that the PCR is the polymerase chain reaction. So colony PCR is getting the DNA from the colony and we'll do the PCR. So the most important is we need to design a primer. So primer is a oligonucleotide that has been attached or ligated or annealed to the single stranded DNA. And then from there, it is doing the extension by DNA polymerase to make a double-stranded DNA, if you recall. So we need to design a primer and then just normally set up a PCR, which we will discuss in our later classes. And then just check by running a gel whether we have detect the insert into the colony we have selected. So the primer design is very important in this colony PCR. So we can either design the insert specific primers, that is just binding to the insert which has been ligated to the vector, or a vector backbone specific primer. So in that case, whatever the insert is, it doesn't matter. So the primer is actually annealed to the vector backbone. So this primer can be used again and again and again, irrespective of the insert. And there is another one is the orientation specific primer, whether the insert is from left to right or right to left, which you will definitely know as you progress through the biotechnology classes, that the orientation is sometimes an important thing. So the insert specific primer, they're really, as I said, that they're really designed to anneal just an insert specific. And this is some sort of an yes and no kind of test result, whether the insert is present or not. But it really didn't give you the orientation of the insert. And in most cases, you need a new primer site. So every time you use a new insert with the same vector backbone, but still you need to design a new primer to check whether the insert is present or not. Backbone specific primer, as I said, that it provides the information about the insert, that whether the insert is present, what's the size. And this one can be used for the primers, can be used for many different insert using the same backbone. As long as you are using the same vector backbone, we can use this primer, but still we can't detect the orientation of the insert. And orientation specific primer, this is a bit tricky. So we need to select one primer for the insert specific, and the other one is the backbone specific. In this way, we can, if we get the specific band when we run the gel, we can tell that which way the insert has been ligated. So this is tell the orientation of the insert, and also the insert is present or not. And this is mainly important for the blunt end cloning, because with the sticky end, the end is already generated. So we definitely know that which way the insert is binding. But for the blunt end, there is no sticky end. So the insert can be ligated to the vector either from left to right or right to left. So this is very important when we do a blunt end cloning. But again, it requires a new primer pair for each insert.